So here this I2 will be referring this this I2 will be referring this I2 this object. I2 will refer this object. Okay, now the data will be as what? Minus 99, and here the data will be as what? Minus 99. Both the objects are having this I1, I2 are having different reference values. So if I use double equals operator, it will give answer as what? False to us, even though the object's data is same, the thing, but the reference values will be different. Okay, now observe here. Let me compile and execute this piece of code. What I have done here, I have created integer object by using new operator. I have created integer objects by using new operator. Whatever, I mean, how many number of times you are taking new operator, that many number of times new object will create at heap area only. So because of this statement, new object at heap area, and because of this statement, new object at heap area. Different object, but both objects type is same, integers only. Okay, so you will get here as the answer false. Okay, observe. Here you will get the answer as what? False. What is the code that we have taken? Integer I1 equals to new integer of minus 99. Other one is what? I2. Now system dot out dot println of I1. Okay, now print that I2 and check both the reference variable values are same or different. Both are different. Here minus 99 minus 99. Also here let me compile this piece of code. Okay, java ctest dot java. 1 second. Okay, let me compile now. Now let me run. Okay, observe here. Okay, observe minus 99 false. Okay, now if I replace this one with just minus 99 without this code, if I replace this one with just minus 99 without these things, now answer will be as what? True, because of auto boxing, value of method will be executing. We have seen that that example earlier. Observe here. If you want, let me take that, take this new integer, all of these things. Okay, now output will be as what? Here true will be the output. Here you will get true as the output. Okay, observe, you will get output as what? True. Okay, let me compile this and let me run. Okay, minus 99 true is the output. Okay, now observe. If I take here minus 129, yes friends, minus 129, then what are the outputs? Minus 129 minus 129, what will be the output here? Output will be as what? False, because observe this here integer dot value of minus 129. Here also integer dot value of minus 129. Both the values are not within this range. What happens? These objects will be creating at heap area, getting at heap area. So here you will get answer as false. Okay, observe. Let me compile and execute even this one also. Minus 1 to 9. Okay, outputs are what? Minus 1 to 9. Okay, so output will be as what here? False. Okay, here it will be as what? False. Okay, why means? Because of value of method logic. Okay, observe here. Let me compile this and let me run this one. Okay, because of value of method you are going to get here as what? False. If I put this one as minus 128, if I put this one as minus 128, now true, because within the range of this buffer area. Okay, now observe. We have understood this logic with respect to the integer class. Now this buffer concept is applicable for all the wrapper classes, and for long class we are having, for long class only minus 128 and 120, minus 128 to 127 values only will be used. Okay, that is 256 blocks only available to use that one. So here for long, if the object data is within the range of minus 128 to 127, this buffer concept is applicable, and for the integer minus 128 to 127, and for the byte minus 128 to 127, for short the same thing, and for float, and for float, and for double, I'll let you know. Okay, I'll come to that point later. Now observe here, for character wrapper class, this concept is applicable only for 0 to 127 values. If you use any value greater than this value and less than this buffer concept will not be working. That object data value must be, if you take integer object, means that data must be, if any data, integer object data you have taken, that data must be within minus 128 to 127 only. If it is like character, that character object data must be 0 to 127. Okay, if it is like boolean, this is wonderful logic within boolean class. They didn't create any buffer, no buffer area available for boolean. Okay, we'll come to know that one later, or else open the source code of this boolean class. You can see wonderful, very tricky logic there. You can feel very great there. Okay, so only for a boolean object which is having true and false, only for them this buffer logic is available, but no buffer memory allocations, guys. Simply they will reuse the existing objects. Okay, that is very good concept, just observe here. Okay, now what I'm going to do here means, let me take this character. Observe here, for long wrapper class objects which are having data within the range of minus 128 to 127, this buffer memory area for auto boxing, that is, if you are creating any long object by using a value such that this value is within the range of minus 128 to 127, this concept will work. Getting? Now what happens, long object data will be as what? Minus double line. That's why at buffer area it will get create. Okay, if I take any value which is greater than 127 and less than minus 128, this concept will not work. That is as object data, very important. Okay, and now for integer we have understood the same thing, and for byte the same thing, and for coming to short same thing. For character 0 to 127 value must be available. If I created any character object with literal as what? EA. Getting? Observe here, we will check this one. Okay, even I didn't check this one earlier, let us understand. Okay, character C equals to A. What's happening here? What's happening here, friends? Auto boxing. Getting? What is that auto boxing? Character dot value of method. character dot value of method will be written by our compiler. Then the same logic will be available within value of method of character class, but range will be 0 to 127. That's it. Okay. Now take one more character class variable, that is reference variable. Now put c equals to c1. Now what should be the output? If buffer object concept is available means true, then you should get the output as what? True. Okay, here it will be as what? A. This is what? C. This is what? C1. Okay, let's check that one. Observe, because A equivalent Unicode value is what? 97. So 97 is coming within the range of 120 0 to 127 or not? Yes. So it will get work higher. Okay, observe here. Okay, let me take that thing. What is that? Character C equals to A and character C1 equals to A. System dot out dot println of C double equals to C1. Checking reference variable values, both must be same. True must be the answer to us here. Okay, because of buffer area concept for auto boxing. Yes, true. Yes, it is what? True. Even for character we are having. Okay, even for character wrapper classes we are having this auto boxing concept applicable for this integer, byte, short, long, character, boolean, but not for float and double. Okay, but not for float and double. What is the default? I mean, between two float values or between two fraction values, let it be 1.9 to 2.9. How many values can get exist? How many units can get exist? Observe any number. Observe here 1.000000093 is one value which can get error. 2.0009, which is the value which comes within this range. You cannot create that many number of blocks at memory. So that's why for float and double wrapper classes this concept not applicable. Getting? That is reusing concept with respect to the buffer area we are not having. Okay, so here only for long integer, byte, short, character and boolean wrapper classes we are having this auto boxing concept, but not for float and double wrapper classes, because within two fraction numbers there can exist any number of fraction values. For that many number of fraction values I cannot maintain blocks, that is memory I cannot maintain. Okay, so that's why this buffer area, that is buffer memory area concept not applicable for float and double wrapper classes. Okay, now let's check with boolean wrapper class. Okay, boolean wrapper class. Okay, now within the boolean wrapper class also we are having what? Value of method, that is we can go for auto boxing. Boolean b1 equals to true. Observe here, if my object data is true or false, then only auto boxing concept, that is auto boxing concept internal uses value of a method, and for that buffer area concept will be applicable. If my object data is either true or false, then only this buffer memory area concept will be used for our wrapper class boolean. Okay, now observe here, now SOP of B double equals to B1. What is the output? True only, because there will be there will be what? An object with the data as what? True. B1. So answer is what? True. Okay, answer is what? True. Observe. Let me compile that particular thing. Okay, now what is that? Boolean b equals to true, boolean b1 equals to, okay. Now system dot out dot println of b double equals to b1. What is the answer? Finally true only. Okay, just for the change, just to have the different output field, let me put one statement. So stars followed by true. Okay, stars followed by true is the output. Okay, now observe here. Now here if I use new operator, friends, if I use new operator here, a new boolean of true. Okay, new boolean of true. Now an object will be creating at heap area because of new operator. Object will be creating at heap area but not at buffer area. No auto boxing code here. Getting directly myself creating object at heap area. So here the data will be as what? Within the two different objects of same type. Okay, two different objects of same type. Okay, two different objects of same type. Now what will be their reference values? Definitely different reference values. So I'll get here output as what? False. Okay, observe, because of new keyword, new object will be creating at heap area. No auto boxing code here. So no buffer area concept code will be executing. Okay, now observe. Now observe here. Okay, now observe here. Now observe here. Let it be new boolean. Okay, new boolean. Okay, observe here. Now b1 double equals to, sorry, b double equals to b1. What will be the output? False. Star followed by false. Observe, getting star followed by false. Getting star followed by false. Now observe here. Now if I take character here, what is that? By using auto boxing I am creating objects. By using auto boxing I am creating objects in our earlier case. Okay, what is that? Character c equals to a. This is auto boxing code right now. New character of a. Okay, once again, character c1 equals to new character of a. SOP of c double equals to c1. Now false. New operator, right? Object at heap area. Okay, observe. Okay, now observe. Let me compile and execute. Just a minute. Okay, character, what is this? A. Okay, now observe here. Now answer will be as what? False. Okay, answer will be as what? As false. Okay, I hope you understand this. Buffer memory area for auto boxing. It is applicable only for the wrapper classes, integer, long, byte, short, character, boolean. If the object data is within the range of -128 to 127 for long wrapper class, integer wrapper class, byte and short, then only this concept will work. And for character wrapper class, if the object data is within the range of 0 to 127, meaning is for character wrapper class, if object data equivalent Unicode value is within the range of 0 to 127, this buffer concept through auto boxing will be working. And for boolean wrapper class, if the object data is either true or false, then only this buffer area concept through auto boxing will be working. Okay, and we have understood even what is that this buffer area concept, how to reuse the objects without any duplicates, why this logic is available or this concept is applicable for these wrapper classes, mister. Simple thing, observe here, simple thing, to use the memory, in efficient way. If I create, observe friends, observe this part, okay, observe here, if I create an integer, observe friends, if I create an integer object by using auto boxing concept, getting auto boxing concept for or else without auto boxing concept, observe, I am going to create integer object without auto boxing concept having same data, observe here, new integer of double line, like this. If I create triple line integer objects with the same data, what happens at memory? Dummy duplicate objects are appearing for 1000 times with data as what? Double line. How many number of times? For 1000 number of times. Okay, I will be referring this one, I1 will be referring this one. Observe here, how many objects? 1000 objects are having same data, getting different objects of same type, What is happening here? Am I using memory in efficient way? No, duplicates are available in greater number, getting. So to avoid such type of misconcept using of memory, they have introduced buffer area concept for auto boxing, and that too if you are creating a new object, it's your observe here, it is your requirement, you can create if you want new object. If JVM is creating an object, observe here, this value of method is developed by whom? JDK developers who designed the compiler and JVM. Okay, who designed compiler and JVM. So those persons has thought as what they want to use the memory in efficient way. Now if I create these objects by using auto boxing concept, for 1000 number of times, the same object will be used for 1000 number of times, only once creating. What is this? Variable. Okay, variable. And what is this? I999. You might be getting one doubt, mister, you have said really good, but to store these variables at memory you want some space, right? Yes, to store these variables I1, I999, you require some space at memory, right? Yes. When you compare an object space and a variable space, this variable space will be 99 times lesser space if it is occupying 64 or else just 1 or 2 KB, it will occupy 0.001 or else 0.1 KB. It will occupy very less space. Observe here, one object creation space equals to 100 or 1000 variables value, getting, that is 1000 variables space will be equivalent to one object value. Approximately I am giving as, but always object space occupation will be greater than variable occupation space. That is, variable storing space will be always lesser than object occupying space. If it is occupying 2 KB means they will occupy 0.01 KB, just for approximate value I am mentioning. So here, observe here, you are creating what? A new variable. If it is like what? New integer of 99, new integer of 99, new integer of 99. Here creating 1000 variables and also creating 1000 objects. For this you have to get memory allocation, and also for these variables you have to get memory allocation. But whereas in auto boxing, what you are doing? We are allocating memory for object only once and allocating memory only for the variables. To greater extent, I am using my memory in efficient way. That is the main advantage of this buffer area concept. Even this concept is applicable for our strings. What is that string buffer area? String constant pool. Some of the programmers used to call that one as what? String constant pool area. String buffer area is called as string constant pool area. Even the memory reusing will be done, so that our application performance will be very good. That is, execution speed will be very low. If it is taking less period of time means very good application. So this is what our buffer memory area concept for auto boxing given by our JDK developers who involved in compiler design and JVM design. Okay, very good concept which has been introduced at our Java. Okay, this is what our buffer area concept. Thank you.